Hello everyone. Welcome to watch Elliston software training video. This time we will show you how to make an implant abutment case. The same we choose this titanium Elliston machine then, the clamping system. This time we import the STL in the home page. We can directly drag the files here. In this case we will show 2 abutment and 1 crown abutment. If we import the STL in this page, it will show the size of the STL. It is very useful to help the user to choose the correct disk. It will also show if the STL have been done or not, to avoid the repetitive job. Let's start. We have already imported the STL before, so the first step we jump to the next directly. In the sequences step, we separate the STLs. For the abutment without crown shape, we choose the Elliston TI abutment. For the abutment with crown shape, we choose the Elliston TI implant good. You can find that the STL with different sequences have different color. Next, in this cavity step, we find that one STL already has the margin line. It is because a margin line file is in the same folder with the STL. It is generated by CAD software. The format of the file is XML by 3 shape or construction ifn by XOCAD. If we don't have this margin file, we can double-click the STL to fast get one. But for the abutment with crown shape, we can't generate so easy. We need to draw it manually, like what we do in the implant bridge. You can select the area as you want. The area below the margin will get the best quality. Next, first we use the magic wand to detect the implant hole direction. Then we define the implant abutment system one by one, from Elliston Implant Library. After we import the implant library, we need to make some adjustment to align the library and the STL. First we use the this function to edit the position with value. We enter a small distance to make the library up or down little by little. And when the Morse taper present this kind of stripe, that means the library arrive at the right level. Here we can also use the rotation function to rotate the library, but it is too complex. I show you an easier way. Here we have a function to align the implant orientation. It is very useful to quick rotate the geometry with polygon. First we move our mouse to the flat surface of STL. Here will come out an axis, click it. Then the Elliston library appear with yellow color. Move mouse to the yellow flat surface and click. The 2 flat surface will turn to the same orientation. Then we go on to the next STL. Define the library. If the library is too different, click the transparent display to show it. This STL is too far away with the library. Here we use another function to quick translate it. Choose one green line of the STL. Then choose one line of the library, which you want to align with the STL line. Two lines are now in the same level. Rotate the polygon. To take care, here we still need a fine-tuning for the level. Remember, Morse taper is the most important standard. Good. Of course, same like the implant bridge, the whole, solid line to the highest, dash line to the lowest. The last ON, we find that here exists a library before we detect it. That is the automatic function. You can ignore it and go on replace manually. Nothing special, just follow what we have said. No matter how many mistakes you make in the beginning, don't forget the whole level. Highest point of this DTL, one mistake here will crash the machine. Next is the orientation. Normally abutment don't need any operation. Jump to the next directly. Nesting the DTL, press and hold a red point to move. Green axis to rotate. Then add the pin. You can add 1 or 2 pins as you wish. If 1 pin, the diameter should be more than 2.5. If 2 pin, the diameter should be more than 1.5. For the pin position, if you design the abutment and crown at the same time, put the pin at the gingival area to make the shoulder clean. If you don't want to manually polish the gingival area, put the pin higher than margin line. Take care when you move the pin too close to the connection. It will be a warning message and then you can't go on. Make the pin away from the connection. Next for the remachining. One by one, rotate the STL direction and use the template TI abutment trimming. Choose existing curve. Yes, the margin line we have definitely in cavity step. Next, rotate the angle if here is some undercut. For the abutment with crown shape, normally we don't do any remaching. If you want to mill the undercut area, the red zone, we can use the sequence TI inlay onlay crown hole 3+2. And here we choose new curve. Draw it manually, just frame the red area. All be done. Go to the last step and just click calculate and wait for the NC file. This is all about the abutment training video of Elliston. Thank you very much for you watching.